For section 6.4, we are going to start multiplying binomials containing radicals. Basically what this means, we are going to FOIL. So remember, FOIL, first outside, inside last. So how do we do this? Multiply, distribute, okay, so an example, we're going to just review FOILing and do an example that does not include radicals. So we're going to start by multiplying our first in each parentheses. So that gives us 10x squared. Then we go to the outside, minus 8x, plus the inside, plus 15x. And then the last, minus 12. And what this gives us is 10x squared plus 7x minus 12. So just a little review. Now, for an example with a radical. Okay, so let's try FOILing with radicals. So we're going to do first outside, inside, last, just like we have been doing. So we're going to have 4 times 3, which is 12, and then 4 times 2 square root 7. So we're just going to multiply the outside numbers together and do nothing with that 7. So we're going to have 8 square root 7. Then we're going to multiply square root 7 times 3, which is 3 square root 7, and then square root of 7 times 2 square root 7. So what we have is square root of 7 times 2 square root 7. When we multiply the square roots of 7 together, that just leaves us with a 7. So to finish the problem, we're going to combine like radicals, which is 8 square root 7 and 3 square root 7. So we've got 11 square root 7, and then plus 2 times 7, which is 14. But we're not done, because now we can combine the 12 and the 14, which gives us an answer of 26 plus 11 square root 7, and we're simplified. Okay, now for this problem, we're squaring a binomial. Now that doesn't mean you're going to distribute the square to each term. We can't do that. We're going to look at it like this. 2 square root 3 minus square root 6 times 2 square root 3 minus square root 6. And then we're going to FOIL it. So 2 square root 3 times 2 square root 3 is 4 times 3, because square root 3 times square root 3 is just 3. And then for our outside, we're going to multiply 2 square root 3 by square root 6. And so that gives us 2 square root 18, which I know we're going to be able to simplify in a minute. Then the inside gives me 2 square root 18. And then plus 6, because the square root of 6 times the square root of 6 is equal to 6. So simplifying this, we've got 12 minus 4 square root 18 plus 6. Now, 12 plus 6, we know this is 18. But we can simplify 4 square root 18, because 18 is 9 times 2, and the square root of 9 is 3. So that gives us a 12 square root 2, and that is our answer simplified. Okay, one thing I want you to notice about this one is that these are identical, okay? Same terms, opposite signs right here, positive, negative. This is actually a difference of squares. This is what we get when we do a difference of squares. So let's FOIL this and see what happens. So we're going to have 4 square root 5 times 4 square root 5. Then we're going to have 4 square root 5 times negative 3 square root 2 plus 3 square root 2 times 4 square root 5, and then minus 3 square root 2 times 3 square root 2. Okay, so what I notice here is that this term and this term are exactly the same, except one's a positive and one's a negative, which means they make a 0. And what I notice here is that the square root of 5 times the square root of 5 is 5. So we're going to have 16 times 5 minus, look down here, 3 times 3 is 9, square root of 2 times square root of 2 is 2, and this gives us 80 minus 18, which is 62. Now what's unusual about this is that now all of our radicals are gone. Everything canceled out. And the reason for this is that the first parentheses right here and the second parentheses have a special relationship called a conjugate, and it is a method that we use for rationalizing a denominator when it's not just a simple root, when it's a binomial. So we're going to move on and talk about conjugates. So as I just said, a conjugate is used to rationalize when the denominator is a binomial. A conjugate follows basically this pattern right here. A plus square root b, a minus square root b. Now those roots can be anywhere. A could be a square root, but what it does is it simplifies to a whole number, to an integer. So it is the same thing, you just change the middle sign. So the conjugate of 3 minus square root 2 is 3 plus square root 2. The conjugate of 2 square root 5 plus 4 is 2 square root 5 minus 4. So we're going to use a conjugate to rationalize these two problems. We're going to start with this one. So we're going to multiply by 1, but the difference is that 1 is going to be a conjugate. So anything you multiply on the bottom, you have to multiply on the top. So the conjugate of 2 square root 5 is 2 minus square root 5. And we're going to do the same thing here. And we need to distribute the 3 here and here when we multiply. So that gives us 6 minus 3 square root 5. And when we FOIL the bottom, remember the inside-outside terms, they are designed to cancel. So we're just going to multiply the first and the last. And 2 times 2 is 4 minus square root of 5 times the square root of 5 is 5. And what we now have is 6 minus 3 square root 5 over negative 1. And what we can do is just take that negative and put it out in the front. And then we can distribute that negative. And we'll have 3 square root 5 minus 6. Okay, so I've worked the next example for you. You see, I multiplied by the conjugate. The conjugate of 1 plus square root 3 is 1 minus square root 3. This is a result of FOILing the top. See, we have 4 terms, first, outside, inside, last. And on the bottom, since the outside and the inside are designed to cancel, all we're going to multiply is the first and the last. Now, I have negatives everywhere. Do you see this? Negative, negative, negative. So I'm going to factor out a negative out of the numerator and the denominator. And so this is my final answer with all of the negatives reduced out of it. And that is how to rationalize a denominator.